Hello everyone, welcome to this exciting tutorial where we'll learn how to create a machine learning model and then deploy it. First, I'll introduce you to my own machine learning model, then we'll dive into how to save the model. Finally, we'll see how to deploy the model step by step. My model is based on the fascinating Titanic dataset. It predicts whether you would have survived if you were a passenger on the Titanic. All the data and the model are available in my GitHub repository, which you can clone to follow a line and create your web application. Let's get started and make sure you have your notebook ready. So, first, we need to import the necessary libraries. This is the foundation of our project. Import pandas as PD, import regularization, RE. Okay, import pandas for data analysis and regularization, and import numpy as NP for numerical operations and working with arrays. And okay, from scalar dot pre-processing, import one hot encoder and standard scalar. um, for encoding categorical features and scaling numerical features. Okay, um, so scikit-learn dot impute import simple imputer, and mm, for handling missing values actually, and for mm, creating machine learning pipeline, I want to import pipeline from scikit-learn dot pipeline from scalar dot pipeline import pipeline. And okay, and from scikit-learn dot compose import column transformer and make column transformer for applying different pre-processing steps to different column. Okay, and okay, and from scalar dot base import base. Okay, for base estimator and transformer mixing. And mm, okay, base estimator and transform mixing for creating custom transformers. And now it's time to import our for example, XGBoost, XGB classifier for building an XGBoost classification model. For example, XG from XGBoost, import XGB classifier file. Okay, excuse me, from scalar dot model selection, import train, yes, split for splitting the dataset into training and testing it. Okay, um, from scalar dot metrics. Okay, mm, from scalar dot metrics, import, for example, precision score. And okay, we can import warnings uh, to ignore warnings for cleaner out. Like this. Warnings dot um, filter warnings ignore. Okay. mm, Now it's time to load our data and create pandas data frame. Okay. pd dot read underline csv. Oh, sorry. CSV and oh, sorry. Um, okay, you can write your um system path and okay. Now it's time to separate x and y data in our data frame like this. If dot draw um survive mm, and let's call one and equal df dot survive. Now let's separate x and y data. And now we can write x no if dot head. And we can see that we have passenger ID survive key class name age. We have age column and actually imported simple imputer to handle missing values. And it is possible to have some missing values in age column, for example. And now we we want to handle the missing values. So now I want to create a class named um, preprocessor with mm, base estimator and transformer mixin. Define fit, self and x and y no. And now I want to create um, age imputer with simple imputer to handle missing values in the age column. Okay, self dot age imputer simple imputer and mm, now we have an age imputer and it's time to fit the imputer on the age column. Self age imputer um, dot fit and x mm, x data age column. And then we have to return uh set. Oh, there's a problem. Hmm? No. And okay, um, we created and actually we'll split the cabin um cabin uh, into two new columns, one for the cabin class and another for the cabin number. And let's use lambda functions to do this. Okay. Mm, transformer itself x equate no. Okay, it's age column. Self dot age uh, imputer dot transform and x etc age column. And mm, okay, and actually for cabin class, you have to uh, write x, okay, capital X, and x cabin column. No, no, no. Cabin class actually. Um, okay, cabin class called except cabin column dot field in a uh, m to handle missing values dot apply uh, lambda uh, lambda function x str x dot dot replace um uh, uh, a space to uh, nothing actually and dot apply mm, lambda function x just or the cell x dot replace um dot replace no x dot result actually or um okay a to z and a to z and okay Um, mm, X. Okay. Where's the problem? Oh, just a second. Okay, I found the mistake. My code, the lambda function, and what is str. Okay, and okay, just a second. What's the problem? Okay, so uh, it is for having class. Um, Actually, um, the now I want to separate having number. Okay, having number. Just a second. I can copy and paste it. Dot apply lambda lambda function uh, x just to x dot replace mm, space to nothing and actually uh, dot apply uh, another lambda uh, x result and okay 0 to 9 and no 0 to 9 and quotation and x data. Okay, that's replace. No, sorry. Um, okay. That's replace. Uh, 0. Okay. Where is the problem? Okay, excuse me. I found mistake. Um, section. So, um, actually, we used to um we created a cabin class and cabin number and actually uh, now it's time to um, impute missing values in the invoked column. Um, it is possible to have some um, missing values in invoked column and we can write x invoked column called uh, we can copy and paste it that fill an A M with M and okay now we can handle the missing values in the inbox column And now it's time to mm, drop mm, drop unnecessary columns from X data. Okay, X um, dot drop um, passenger ID. Um, actually, name, name and name and ticket. Um, and cabin because now we have cabin class and cabin number. Okay. Mm, axis one and return X. So, okay, now we'll create two pipelines, a standard scaler for numerical data and one hot encoder for categorical data. Uh, at first, I want to um, create an object first, like this. We we have it in decline, um, and excuse me. Now we have to uh, create our pipeline. Um, pipeline from we have pipeline in this line. Um, pipeline. Um, okay. Um, name scalar, for example, and standard scalar and categorical pipeline. Pipeline. Okay. For example, um, one hot and one hot encoder handle on now. Uh, we ignore and okay, and mm, now we can make a transformer with column uh, transformer um, named num, for example, and numeric numeric pipeline on, for example, P class and on age column, on siblings, and, for example, fair, and mm, having number, having number. Uh, okay, actually, um, okay. For example, categorical cat, for example, and categorical pipeline. For example, gender, just a second. Mhm. Import and for example, um, cabin class. Okay, but a process. Okay, um, and now it's time to use train test splits. Um, like this: x train, x test equal train, equal test. Okay, train test split um, to x and y with test size, um, for example, mm, just a second, um, for example, 1 um, 0.1 to separate x data and y data with mm, random state, for example, 42. And okay, in the next cell, we can create our machine learning pipeline. ML pipe, for example, with pipeline, for example, initial preprocessor, preprocess. Um, we can write preprocessor and mm, sorry, and for example, tra- transformer um, to uh, transformer and actually our model. For example, I imported XGB from XGB classifier, and for example, name XGB XGB classifier, and okay, and we have to fit our model in a pipe that fit on X train and train data and Y train. Uh, where is the problem? Okay. I guess the problem must be with this cell. Yes. Mm, capital capital I, and capital A. Um, okay. Small x and small x. Okay. So now we created our model with a pipeline, preprocessor pipeline, and a column transformer uh, that is applied a standard scalar on uh, numerical features like p class, age, and etc. And one hot encoder on categorical features like in work and cabin class and XGB classifier. So now it's time to predict our model like this. We could have ML pipe, a model dot predict X test and test data and Y hat and for mm, accuracy we can write um, from the scalar.metrics I imported precision score and we can write precision score and Y test and between Y test and Y hat and it is 70 about 73%, but it could be more accurate. Um, no problem. We can skip it, and now it's time to save our model. So um, mm, we imported. We have to import job and to save our model and joblib dot dump um, our to our model and pipe uh, okay and pipe and a name, for example xgb pipe dot joblib and save our model, and now we can load uh, our machine learning model like this. For example, model call joblib joblib.load, name our model, for example, xgp5.joblib, and okay, and load our model, and then we can create test data pd dot with underline csv, uh, for example this, for example um, streamlit test.csv, and okay, where is the quotation? And now we can see uh, test dot mm, columns, for example, and it's all down, and we can create a new uh, prediction y hat model dot predict and test data, and hat okay, and actually um, we could save our model. And in this video, we saw that we made a machine learning model very easily and trained it and finally saved it. And in the next video, you will see how to build a web application and deploy it. I will be back with a new video very soon. Goodbye, have a good time.